All right, I'm super excited about today's lab. We are going to be doing a titration. What's a little bit different about our lab that we do in class compared to other titration labs you might see online is we actually create the base that we're going to find the concentration for. We're going to do essentially a dilution, all right? So in the lab for day one, you'll see that it says to take some 6 molar sodium hydroxide, and that's what I've got here, 20 milliliters of 6 molar sodium hydroxide, and actually add it to 200 milliliters of distilled water. I've already got 100 milliliters of distilled water in here. I'm gonna add the other 100. All right, so now I have 200 milliliters of distilled water in my Erlenmeyer flask. I'm gonna add the 20 milliliters of sodium hydroxide. Remember, it's 6 molar, but now we're diluting it because, of course, we're adding it to water. I'm gonna give that a little swirl, and you'll notice that I've actually labeled it sodium hydroxide. And I could put 0.5 molar on there, but we're gonna find out what the exact molarity is by doing a titration. Let me show you what we would do in regards to calculating what our concentration should be at based on what we just did, right? According to our dilution equation, we're gonna take the molarity of our sodium hydroxide, 6 molar, and we took 20 milliliters, of course this is written in liters, but we took 20 milliliters of that 6 molar sodium hydroxide and we put it into 200 milliliters of water. Now that gives us 220 total milliliters of solution. So if I'm trying to figure out the molarity of that 220 milliliters of final solution, right, I can just simply solve for M2. Here's our calculation. You'll notice that liters cancels out with liters, and I'm left with a concentration of 0.545. Of course, I'm going to use 2 sig figs here because my molarity was only written in 2 sig figs, and that's going to put us right around 0.55 molar, okay? So now we have sort of a target to shoot for when it comes to doing the titration. All right, so that brings us to part 2, actually titrating. I'm excited about this, can't wait to show you what it looks like with the burettes. Let's do it. All right, I know you want your calculations to be accurate. So before we add our base to the burette, we need to think about, shoot, did I clean this? And you probably did, actually. The problem, though, is that when you cleaned it, if you rinsed it out with some distilled water, there might still be distilled water in the burette. Well, what's that gonna do to our base when we add it? If I add my base to even a few drops of distilled water that might reside in the burette from cleaning, I'm gonna dilute my base. That's not a good thing. The same is true if I go and add my standard acid solution to my acid burette. If I think that this is 0.5 molar, which it is when it's in my bottle here, but if I go and I add it to the burette that has water in it, I'm now diluting my 0.5 molar HCl, and it's not 0.5 molar anymore. So we gotta do a couple things, all right? Number one, we need to add just a little bit of the base to our base burette, and for the acid, a little bit of this acid to our acid burette. And when we do that, we're gonna pour that in. Now notice that I took this out of the stand. I'm not going to try to pour base above eye level, or acid for that matter. It's not safe. You gotta take the burette out of the stand and add any of your solutions below eye level. The other thing you wanna make sure of as well is that your stopcock is actually closed. This is called the stopcock. It's the knob that controls the rate of flow of the solution that's in the burette. Right now, when it's perpendicular, there's no rate of flow. It's closed, all right? When I open this up, and you might see some come out here, when I open this up, you'll notice that open all the way. I get flow coming out of my burette. Of course, you can vary that rate of flow as you turn the stopcock, all right? And you'll do that a little bit more later with me. But make sure the stopcock is closed unless you want to look like you peed your pants. Not a good idea. I've seen some kids go filling up their burettes like this, stopcock's open, and they're getting some solution on their pant legs. Not good if it's an acid or a base as well. All right, so stopcock is closed. I've got my funnel, which I also rinsed with some of my base. I already did the same thing for my acid, burette, and funnel. And I'm gonna pour this slowly. These things fill up quick. It's really easy to think that you're not going fast and all of a sudden, boom, you're overflowing your burette. Stopcock's closed, got my burette below eye level, and I'm gonna add my base. I'm gonna keep track here of how quickly it's coming up. Now I don't need to hit it right on the 0. If I do, great. If I'm below it, that's fine too. Doesn't matter, okay? I'm a little bit above the 0. I'm gonna pull out my funnel and we'll talk about how to adjust this in just a little bit, okay? So awesome, I've got my base in my base burette, I've got my acid in my acid burette, and we are good to titrate. So let's go ahead and get to it. All right, so we're ready to titrate, and I'm gonna take this beaker that I put my waste acid in and get rid of it. And I have my 125 milliliter Erlenmeyer flask ready to go. Now I put some distilled water in there. You were supposed to put 20 milliliters of distilled water in here. And this is really just to help us see the color change a lot better. As we add milliliters of acid and base to this water, it's gonna spread the color out more so that we can see it. Now, a couple of kids had asked me one time, hey, Mr. Schultz, won't that dilute the acid and the base? Yeah, it will, but we care more about diluting the acid and the base in our burette here than we do in here. You see, it's kind of like this. If I have 5 kids and I want to keep track of them, right? It doesn't matter if they're in a small pool or a big pool. Basically, we're taking all our kids, all our H pluses and our OH minuses, and we're throwing them into a pool, right? And it could be 20 milliliters, it could be 30 milliliters of water. It doesn't matter. The color change is gonna tell me when we've reached our endpoint. So as they go into our Erlenmeyer flask, it doesn't matter that they're interacting in a pool, basically. They're kind of all playing in the pool and eventually they're gonna cancel each other out. So it's okay that we've got water in this Erlenmeyer flask. Before I do anything though, I need to add 3 drops of phenolphthalein. Now the phenolphthalein is the indicator that we're going to use. 1, 2, 3. And that's going to stay clear when it's in water, and it's also going to stay clear when it's in our acid. So let's go ahead and add our acid. I'm going to actually take my hand, wrap it around the burette, and I'm going to add acid, and I need to move here so I can actually see what I'm doing. See how many milliliters of acid I'm adding. Remember, I'm at 0.3 right now, and I want to get down to about 15 milliliters. So I'm going to shoot for 15.3. I'm going to go ahead and add my acid. I'm going to open that stopcock all the way. No need to swirl right now because I'm just concerned about getting my 15 milliliters of acid in there. I put a little black piece of paper behind the burette, so hopefully you can see the milliliters that are being added here. I'm gonna slow it down a little bit more as we get closer to 15. And remember, I'm shooting for that 15.3. And to make sure that I am right at 15.3, I'm going to get about eye level, and I think I hit it right there. So let me get a better look. I got 15, 1, 2, I might have to go down another milliliter, but that's okay, all right? It doesn't matter. Even if I overshoot, and let me see if I can just get it to drop one more. Even if I overshoot, it doesn't matter because what matters most is that I know the exact volume that I'm putting in here, okay? So, looks like I have my initial volume at 0.3. I've got my final volume at 15.3, which means I put in 15 milliliters of my 0.5 molar acid. I know my MA and my VA. It's time to figure out what the molarity of our base is. All right, it's time to add our base. And our base, if you remember, we calculated it to be about 0.55 molar. Now the acid that we have in here right now with the phenolphthalein, but the acid that we have in here right now is supposed to be about 0.5. Now, if they were both 0.5, you would think, oh, 15 milliliters to 15 milliliters, based on the chemicals we're using, hydrochloric acid and sodium hydroxide. It should be a pretty straight shot. But because we have sodium hydroxide that's a little bit more concentrated, I'm probably gonna need to use less when we titrate. So the first titration is always kind of a test run, all right? We're gonna shoot on down, maybe throw about 7 to 10 milliliters in there pretty quick. We're gonna get some color change, and then we're going to see when we finally reach that endpoint. It's okay if you mess up on this first one and overshoot. It's really just to kind of give you an idea of where you're at for the next few trials that you run. Let's give it a try. In here, I've got my acid. Of course, there's some water and phenolphthalein. Right now, if you look at my base, I took the time and I made sure that I was actually right at 0, so that's my initial volume. Don't forget to record your initial and final volumes on your lab sheet. And so here we go. I'm gonna go ahead and shoot about 10 milliliters right off the bat. And again, if you overshoot, it's okay. I'm gonna keep swirling until I get that color change. Now, in our trials coming up here, we will go drop by drop and really try to hit the nail on the head, get it exact. Let me stop the flow here and see if it stays. Color stayed, okay? Now, I'm gonna be honest with you. If you keep mixing really, really hard, you can sometimes get this color to disappear. And that's because if you're splashing around just the room air in the water, that carbon dioxide actually will mix with the water and make carbonic acid. It will make it a little bit more acidic. You don't need to do that, all right? If you swirl it for about 5 seconds and you see that there is a continuous light pink color, you've reached your endpoint, okay? You might also notice that there's a drop on the end of the burette here. You don't need to try to shake that off. You can take your water bottle and actually rinse that into your Erlenmeyer flask, okay? And now you've included that volume of base. So let's take a look at where we're at. If we look at our burette, we'll see that we got down to right around, wow, we went from 0 right to 15. We are right on the money there at 15.0, okay? So that gives us an idea of the concentration of our acid and how much acid and base we're gonna need to use in conjunction with one another. So now we have a good basis to run our next 3 trials, okay? The lab calls for using 15 milliliters of acid and base each time. We've filled our burettes with 50 milliliters of acid and base, so we could actually run the trial 2 more times based on what we just saw. You might have a lab in college that calls for you to only use 10 milliliters. That's fine too. Just remember, when you increase your sample size, you get more precise. So using a higher volume as opposed to, let's say, 5 milliliters is gonna give you better results. All right, so now for your second and third trial, you're just gonna do the exact same thing, all right? I have already dumped out our last trial. Acid, base, phenolphthalein, completely dumped, completely rinsed, and rinsed out with distilled water. And now I have my 20 milliliters of distilled water in there. I'm of course going to add my 3 drops of phenolphthalein. So I've got my indicator in there, give it a little bit of a swirl, and I have my acid ready to go. I'm gonna add my acid. Now remember, I didn't have to fill the burette back up to 0. I know my initial volume right now. It's at 15.3. I wanna add about 15 more milliliters into my flask. And so I've recorded that I'm at 15.3, and I'm gonna shoot for about 30.3. If I overshoot or undershoot, no big deal. I just write down whatever it is I end up at, okay? So let's add our acid to our flask. Opening up the stopcock, letting the acid flow in there. And we're gonna do the exact same thing for trial 3, okay? We're gonna record our initial volume, which will probably be right around 30.3. And of course, add our acid and then our base and titrate the same way. 3 trials makes it so that we can get an average and have a nice, precise, and accurate result. So I'm getting close here. I'm gonna slow down my stopcock. I'm right at 30. So I'm gonna go ahead and I could just stop right here at 30 if I wanted to. All right. And so I'm gonna add my 3 drops and just see how, oh, look at that. I'm right at 31, 32, and here we are at 30.3. Okay, the next one I'm gonna mix it up a little bit, but now I know I've got 15 milliliters of my acid in there, and now it's time to go ahead and add my base. Yeah, I've got my base at 15. That's the initial volume for my second trial. Second trial, we're at 15. We're gonna put 15 milliliters in. We're gonna see some color changing here. So let's go ahead and add that. Got my stopcock open. It's gonna flow a little bit slowly here. So because I know last time it took me about 15 milliliters to get to where I needed to be, I'm gonna shoot for about 30 and slow it down. You'll notice if I give it a swirl, that color change goes away. I'm getting closer here, so I'm gonna slow down right around 29. Slow my rate, and let's see if I can keep that color or not. Nope, color's disappeared. All right, I'm right at 29, as you can see here, a little bit below, actually above 29. And I'm gonna add some more. Give it a swirl, disappears. Keep going, maybe drop by drop here. Let me get my hand out of the way so you can actually see that. Ooh, we're really close. Let's try again. Oh, maybe overshot. Definitely overshot. So I'm super close there. You would want to stop right now. I'm going to add one more drop if possible. See if I can get that color to stick around. Let's see what we get. We get that nice color change there. We get that endpoint. Okay, so super important that I notate where I ended up. If I get eye level with my burette here, I can see I'm at 30.1 milliliters. Okay, so I'm gonna jot that down. All right, we're here for our third trial, and we are going to add our last bit of acid into our flask. I've already added the phenolphthalein, I've already added the distilled water, and so now we've just got to put our acid into the flask. Right after, we'll do the base and titrate it, see what we get for a concentration after our 3 trials. So you'll notice I'm at 30.3. All right, again, I'm gonna shoot some acid in here. Shouldn't see any color change, of course, because remember, phenolphthalein does not change color in the presence of an acid or in the presence of water. It's just gonna stay clear. And we're just gonna get a little crazy, right? I guess as crazy as you can get with titrations. Instead of trying to do exactly 15 milliliters, I stopped at 41.2 there, okay? So that's gonna be our final volume for our acid, 41.2. You're gonna wanna make sure that you notate that on your lab sheet. All right, now I've got my base in place and we can see the volume there. Okay, so I'm gonna add my base, and since we went to 41.2, that puts us at about 11 milliliters. That means instead of adding 15 milliliters of base this time, I'm gonna try and add about 11 milliliters, 10 milliliters of our base, all right? Last trial, let's titrate. Remember, I started at 30.3, I'm adding my base. And I'm gonna wanna go down to about 40 and then start to slow down. I know I can leave my stopcock open all the way down to 40 because of my previous trials. Again, you might think, oh, look, it's changing color, but that will go away with just a swirl. We're getting closer though. You'll notice we're at 40, and so I'm gonna stop that, give it a swirl just to check, and our color disappears. So, let's go a bit slower now. About 3 or 4 milliliters in there. crazy. And so now let me go drop by drop. Sticking around. Oh, 2 drops went in. Close. 1 more drop. Two drops. And we've got our color change. We've reached our endpoint, okay? You'll notice that that color disappears. And again, we could add another drop. This is why we do 3 trials. When you see that consistent drop, change the color and it stays for more than 3 to 5 seconds. When you swirl, just like that, you know you've reached the endpoint. Like I mentioned earlier, you might swirl a little bit vigorously and a little bit harder and that color might disappear. If that happens within 3 to 5 seconds, you need to add another drop, all right? So I'm gonna record my volume. You'll see that I am now at 40, actually I'm right there at the bottom of the meniscus at 41.0. So I'm gonna record that, and I've got my information now that will allow me to calculate an average, which will give me the molarity of my base. All right, so as we did the lab, we were writing in our data, and you can see this table is a great place to organize your titration data. You'll have a similar table if you do a titration in the future, where you have the molarity of your acid. This was our standard solution, so that's why all of them are already 0.50 molar. You'll notice the volume of the acid that we got as we recorded the initial volume and the final volumes for each trial. And then, of course, we had an initial volume and a final volume for each trial with the base. We were able to subtract the initial volume from the final volume to get a total volume of base that was added until we hit the endpoint. We then were able to calculate the molarity of the base just by solving for MB. We knew this value, we knew this value, we knew this value, but we didn't know the molarity of the base. So for each trial, we solved for MB, the molarity of the base. Once I got each trial's molarity for the base, I then took all 3 of my trials, added them up, divided by 3, and found the average. You'll notice here my calculator spit out some extra digits that it didn't really know. And so, of course, using 2 sig figs because of the standard solution that we had, we went with 2 sig figs for our final answer, even though this says to go out to 3. All right, and that's how you find the molarity of the base. So that's how you set up a burette, do a titration, and finally reach an endpoint. You guys are gonna do a great job with any titrations that you have to do in the future. Of course, if you have any questions about how to titrate, how to do the calculations, or set up anything related to chemistry, let me know. Good luck, and I hope to see you in the future.